We've been talking quite a bit about the importance of modular design, but the thing I realized is that I've never really talked about how you actually do modular design. We've talked a lot about how you evaluate if a module is good with the PyCI metrics, the 5 essential elements. But how do you actually do it in the real world? How do you design modules? And here's the thing. It isn't just for principals and architects. It isn't just for the beginning of projects when you're designing everything. Modular design is actually something that everyone should do at all levels of skill every day with every piece of code that you touch. Today, I'm going to teach you how to do modular design in the real world, and I call this Organic Modular Design. Let's get into it. Hello, I am Shane Brinkman-Davis-Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today, we are going to talk about organic modular design, or how to design modules in the real world practically. And here's the key thing. You're not really going to design modules, not in the sitting down at the whiteboard with your team, thinking through heavily how you're going to design a module. It is much more like an evolution of modules than like an intentional design. Now, of course, every step of the way, you will be coding, you will be writing your code, you will be directing this, but you'll be doing it in small increments. The thing is, your code base is much like a garden of modules. You will have modules in your code base at all levels of the modular life cycle. And that's primarily what we're going to talk about today. I'm going to walk you through the modular life cycle and how you take a module from each of the various levels in the life cycle and advance it just a little bit every time you touch the code so that your code base continually gets more and more modular. Let's start at the top. Where do modules come from? The primordial soup of modules comes from your code. As you're working along, you will start to have some repetition of some sort or another. You will start to have bits of code that look similar to other bits of code. Either literally there will be outright repetition over the same string of characters, or it'll be roughly the same pattern over and over multiple times. And when you see that, you're going to do one of my favorite things, and this is the first of the 2 prototypes of this video. You're going to dry them up. You're going to honor the rule of don't repeat yourself as soon as you see a repetition. And this is the first trick to being a master modular designer, is don't wait when you see repetition. You got to work on that repetition immediately. The more you wait, the harder it's going to be to work with later. But when you see that repetition, you should get excited because you're like, aha, out of the magic of nowhere, the primordial ooze of your code, you now have a module. You dry up that code, and the first step of any attempt to dry something up is usually to make a function. You make a function which expresses the pattern, and it has as its inputs the things that vary the pattern among its different repetitions. And then you use that function instead of each of the hard-coded repetitions you previously had. You now have the smallest module. It is a function. Now, functions are actually pretty good modules in a lot of ways. They have a strong external interface. The implementation is well encapsulated. Users of that function can't get access to the implementation directly. Some functions are better than others, but you can certainly make it pretty good so that the interface does not expose a lot of what's going on in the implementation. It's a function. It does something a little useful, and it really dried up some repetition. And sometimes when you dry up the repetition, you don't even really have a good name for the function. You just know that you're making your code less repetitive. And perhaps what you have identified is a simple string function that does some simple string processing for you. Now, you're going on and you're making progress in your code again. And you're doing this process of whenever you see repetition, you dry it up and you make a function. And now you might start to notice you've got several different little functions that you've been using now, which are all string related. So you put them all together and you start to form the next level, and you put them all in a file. Files are modules. All functions are modules. All files are modules. And again, as you're putting things in the file, you're going to be applying the PyCI requirements. Every step of the way, when you're looking at these things, either functions or files, you've got to be thinking, how can I make this the best module it can be? So you apply the PyCI. You say, well, what's the purpose of this? Well, it's a string lib. Let's be realistic. It's not the best purpose. It's not highly focused, and it's not super tied to human needs. And actually, let's just comment on that for a second. What does it take to have a good modular purpose? Really, the two main ingredients are, can you connect what that module does all the way back to essential human needs, which is, think Maslow's hierarchy of needs. You got the physical needs like nutrition and water and heat and shelter, and then you've got social needs, and then you've got the enlightenment needs, or becoming part of something bigger than yourself, at the top of the pyramid. You can slice and dice those needs several different ways, but fundamentally that's what life is about, and that's where all motivation comes from. Can you tie your module, and it may not be directly back, but eventually you should be able to tie it to, how does this serve a bigger module, serve our product? How does our product go out in the world and serve real humans for their real human needs? The other thing a good purpose does is it makes a very clear line between what should be in the module and what should not be in the module. It makes it very clear. And a string lib may at first seem, all right, well, it tells us a little something. It doesn't really connect back to human needs. Although this is a hypothetical example, you could look at that and say, how does this actually serve our product? And you would maybe connect it back a little bit, but it's still pretty vague. But the string lib does sort of say, well, you're not going to put math functions in there. You're going to only put string functions in there. But if you realize after a moment, there's a great deal of different kinds of string functions in the computing world. For example, a compiler is just a string function. It takes in a string of code and outputs a string of compiled code. So it doesn't really give us super good indicators of what should go in or shouldn't go in, but it's a start. And that's part of my point about this whole process. Every step of the way, it's just about making it 1% better. It isn't about making it perfect. It isn't about worrying about where it's going eventually. It's about where is it right now and how are we going to make it a little bit better. We're now accumulating some functions in a file, and we've got a purpose. Next, we're thinking about the interface. Well, if you're in a language like JavaScript where you have to explicitly export things, that's pretty good because now you know by exporting things that is your interface to that file. That file is a module and its interface is what's exported. And initially, you're going to have what I call the thin veneer module, where you're exporting every single function that you have inside that file. And that's just fine. That's a fine place to start. You already have a little bit of leverage because the internals of the function are usually a little bit bigger than their interface in terms of their inputs and outputs. So the complexity of looking at your exports for this file is a little bit simpler than looking at the actual implementation of the file. But it's still not great. You still have very much a one-to-one. And here's the main reason that's a problem, is because anytime you want to change those functions around, add functions, remove functions, you're going to break your clients. Your clients pretty much directly dependent on the implementation. Now, you can tweak the inside of one of those functions, and it doesn't necessarily affect your clients, but you're pretty locked in because you've got a very tight coupling between your interface and your implementation. So it's making some progress, but it's not there yet. The good news, though, is that the encapsulation is quite strong. If you do have some internal implementation that you don't explicitly export, maybe you've got some constants or something that's helping you out at the moment, and you're not exporting those, well, those are free to change arbitrarily without breaking any clients because only what is exported can be accessed outside. So you've got pretty strong encapsulation. Files have some things going for it. And in fact, I will say in a lot of projects that I've worked on, people tend to do a pretty good job of modular design at the file level. So remember I told you I was going to give you 2 pro tips. And the first one is dry things up as soon as you see it. That's what I do not see on most projects. That is one way that you can level up past your peers. Modular design at the file level tends to go all right on projects. People seem to get that concept. But now we're going to lead into the second pro tip. So you're now gathering this file together, and you might eventually gather a couple of files together, and you might put them into a folder. A folder is also a module. All folders are modules. And just like all modules, you want to apply PyCI to that module. You want to say, all right, I have this folder. What is its purpose? What is its interface? What is its encapsulation? How are we enforcing encapsulation? What is its implementation? How does this thing work as a module? And again, the whole reason why we're modularizing things is so that we can defeat the network effect, as it were, where everything can be connected to everything. That's where we get quadratic complexity growth. We want to flatten that the other direction, and we want to make the interface 10 times simpler than the implementation. In fact, you want to make it 10 times smaller code-wise, which makes it 100 times simpler, because 10 times bigger means 100 times more complex. That is how we get our leverage, is by enforcing strong encapsulation and making a simple interface around a more complicated implementation. Well, here's where most projects fall down. They don't treat folders like modules. And most specifically, they don't enforce encapsulation at all, not module. So files in that folder are free domain. Anyone from anywhere else in the project can reference files in that folder, or subfolders in that folder, or sub-subfolders. If you look at pretty much any project and you look at the require statements, you will see requirements that go folder name /file /folder name, multiple slashes in that requirement. Each one of those things is puncturing into the private part of a module. So here is pro tip number 2. Pro tip number 2 is treat every single module, every single folder as a module, and all files and all subfolders within that module are 100% private. This is just requires buy-in of everyone who's working on your code, but basically you have to say you can't ever require into a folder. It's actually pretty simple. It's a simple rule to apply. It means whenever you ever require paths to something, you can do // // You go back up the structure, and then you can say /one folder name, foo, but then you can't use any more slashes. You can't go into that folder. You can't go require anything inside that folder. What you can do, and this is how you're going to get started. You're like, all right, I've got several different sort of tools we're pulling together that kind of make sense to group them into a folder. In JavaScript, you just add an index.js file, or in Python, you have a _init file, or any number of other languages have similar ways of doing it. You make your exports file, and it's totally fine. And this might feel like a cheat or a cop-out, but it really isn't, to export everything. Just make that index.js file and export all the other files, just do export star. That is totally fine. And here's why. It is not the same thing as allowing people to path into your module and access its private parts. Even though you're exporting everything, it feels like you're exporting all your private parts. You still don't have any private parts, right? Well, no. Because you're forcing people to only import your folder, not any of the parts inside the folder. Even though you're exporting everything, you are still free to completely arbitrarily move your files around, move functions between the files, rename your files, whatever you want within that folder, and it won't break anyone. This already is a major step up in your folder and your PyCI, in particular on your encapsulation. You can do a huge amount of refactoring and restructuring of that module without breaking a line of code anywhere else, without having to change a line of code anywhere else. Now, you should be trying to level up your purpose. And so let's hypothetically say that you have started to notice that a lot of these string functions that you're working with really are just taking, say, database data and converting it into something that's very human readable. Typically, we call these things presenters. So now we have a presenter lib. And we've got a folder with these presenters, because now we've got a lot of them, and they share some common stuff. Like we've got date presenters, and we've got time presenters, and we've got presenters for presenting, say, JSON structures into HTML in a way that's human readable, right? So we can have a fairly complicated library that's just doing presenters, and now we've got a fairly good purpose. It serves human needs in terms of allowing people to understand what's going on better. It serves human needs for developers, because it lets developers very quickly make human readable output from their more complicated data structures behind the scene. It's getting more connected to human needs. And it also is more defined what goes in and what goes out. Clearly, at this point, compilers are not in there. And maybe you're initially exporting everything, but then you are going to start drying up your code inside this folder. And those dried up functions, no one else needs them. They're just for you to dry up the bits of code in your folder. Don't export them. You are going to start to have functions that you do not need to export. Conversely, you might realize you didn't really need to export all of the other functions you were exporting. You might realize, oh, no one's actually using that function. We're only using that internally. Stop exporting it. So now you're going to start to increase your interface to implementation ratio, which is to say your interface should be much smaller than the implementation, hopefully at least 10 times smaller. Now you're starting to get the real leverage of having a full module. At this point, we've advanced, moving along, growing our various modules. And a folder can be a pretty robust module at that point. You control the exports fully with your index.js file, and it can be fairly complicated what's going inside it because it can be a folder. It can have its own submodules of its own subfolders. And note, those subfolders also are modules, and also their private parts. Your parent module can't access those either. Every step of your hierarchy is an isolated subtree. No one can reach into that subtree of your folder hierarchy. Those are the private parts. Only access what's exported. And the reason is because you need to have that hard line to balance between the inside and the outside to have that encapsulation, which is what makes the clients get a much simpler experience so that they can scale further without having to deal with more complexity, and it allows you to work on the intros of the module without breaking any clients. Now, we have a folder. It's going pretty well. We are paying attention to never reaching into a folder, never importing a file from some other folder or a subdirectory from some other folder. To be clear, you can import peer files or peer folders or folders that are in a peer of your parent or your grandparent in your folder structure. You just can't reach into a folder. You can reach out of a folder, but you can't reach into a folder. Now, that may be going all very well, but now we can get to the last step of the modular lifecycle, and that is packaging up your module. Now, there can be two good reasons to package up a module. The first one is fairly obvious. Say we've got these presenters. They're getting pretty mature. They're working well. We've got tests. We've been doing modular testing, which I'm not going to get too much in here, but that's very interesting how modular testing works with this organic modular design, as you might imagine, but that's a topic for another episode. But you've got tests for this module now, and you're testing the module from the outside, a la modular testing. And you're like, okay, this is getting pretty mature, and I'd like to use it on other projects. Or I just like to open source it and share it so other people can use it on their projects. So you want to package it up. In the JavaScript world, this pretty much means publishing it to NPM. You might go ahead and put it in its own folder, make a package.json, and that's awesome. But there's a whole other reason why you might want to package it up, which has nothing to do with sharing it anywhere else. It's that when you package something up, you get to, rather than having a convention of you're not going to require the files and the folders inside this module, you're only going to require the exports, you can enforce that now. When you package something up, it is now enforcing that people cannot reach into your module. Further, it solves several problems that might be plaguing you and you may not even know it. It's very easy inside your module to, one, you might accidentally be importing something that you didn't know you were from elsewhere in this code base. You're probably building up this module as part of a bigger app, and you might have dependencies in other parts of the app you didn't realize that you had. And you may not even want them, but you didn't know that you had them. Well, when you package something up and put it into its own folder with its own test, it's going to become clear very quickly that you don't have all the dependencies it needs. Similarly, you may not fully understand what third-party dependencies you have. You're just using the mess of everything that's in your parent folder's package.json, everything that it's importing in its dependencies. You may think, oh, this is only using 2 of those, right? And you may be wrong. But if you make it into its own package and you have its own dependencies and you can run its own tests over there, you will very quickly know if those dependencies are sufficient to pass your test. So you can get a much better understanding of what the external dependencies are, which will further improve the implementation of your module, because one, you'll minimize your dependencies, which will make it more robust, and it will also make it smaller for people who want to use it. So that's a lot of wins. But yet another problem that might be happening is even though You might have the best of intentions of never pathing into the module and reaching in and touching a file or a subfile. Everybody knows sometimes you got to push something out quick and you got to do a quick fix to solve it, and you violate the rules temporarily to get there. And that's totally okay. I got no problem with that. But the pernicious thing about that is it can be easy to forget that you did it, because when you go back later and review that module, which is to say every time you touch that code, you're going to review that module a little bit and say, how is this module doing? Is it good on the PyCI? You won't see that that exists because that transgression is happening in some other file somewhere else in your code. It is not happening in your module itself. So when you're saying, is this module good? You'll look at it and you'll think it's good, even though somewhere else in your code, something is reaching into your module and using a private part. Why is that bad? Well, because you're going to think you can change that module arbitrarily, but you can't. It'll break something else, but you don't realize that it would. All of these reasons are great reasons to package up a module and promote it all the way to a fully mature module. Oh, here's a couple other benefits of packaging it up. Documentation. All of a sudden, it makes natural sense to start documenting that module very clearly and strongly defining its purpose. You make a README file. You want to have a little pitch about why this module exists. You have a little tutorial, how do you use it? Like all of a sudden, this module grows up. You are the proud parent of a fully mature module. Now, here's a little plug for Monorepos. Personally, I'm a huge fan, perhaps because of how much I do gardening of modules. I am always producing new modules all the time, and once it gets mature enough, I'm always wanting to package it up so I can have that extra level of assurance of what's inside and what's not inside my module. I love Monorepos for exactly this reason, because it allows you to package up your various modules, but keep them going in your same main repo. That's totally fine. So it doesn't have to disrupt anybody's production. You don't have to, particularly if they're modules that you don't want to publish publicly, you don't have to go worry about setting up your own private module repo or use some third-party repo that you have to pay for. No, you just put them on the same GitHub repo. It works great. So now we've sort of covered the basic life cycle, but there is this concept of life cycle. So let's just touch on that just briefly, because I've kind of hinted about that all the way along. As you're getting to the files and the folders level of your module, you're still drying things up. Every time you go in, you notice something that's a little bit repetitive, it's a little bit wet, you're going to dry it up. And in doing so, you are going to start to create new little functions and then gather them up into new little files. And those files and functions are inside one of your other proto modules that says at the folder level. And maybe that happens and you start to have more files at that folder level, or you group those files together into subfolders. Those are modules growing inside of another module. And so yes, at some point you'll have a packaged up module, and guess what happened in that module? It'll start to have more functions. It'll start to have more files. It'll start to have those files organized into folders. Every step of the way, you're going to use the PyCI metrics to say, are each of these little bits good modules? Are we doing the best we can to encapsulate them? Are we really enforcing that we never reach inside a folder or reach inside to touch a file or touch a subfolder? And thus, your module, which you packaged up yesterday, today, you might discover, oh, I've got a new file module growing inside that packaged up module. And in fact, that is how the life cycle of modules continues. Every developer should be doing modular design every day. Even junior developers can do this. It is a little bit hard to get used to drying things up all the time. That is the first hurdle that everyone's got to work on to get over. But I don't think it's any more difficult for a junior developer or a principal engineer who hasn't gotten that under their belt. It's just a practice you got to start working on. Every time you touch code, pen to code, you got to say, is there repetition here? Do I see them repeating? And after a little bit, it gets a lot easier. You start to just feel irritable. Not that I want to encourage people to feel irritable, but you get this little antsy feeling when your code is kind of the same over and over again, when you're writing the same sequence of symbols over and over again. And you go, I'll bet I could dry this up. I bet I can make a function out of this. So that is pro tip number one. Get things dried up. Once you're drying things up, then the rest of the life cycle actually goes pretty easy as long as you can remember to apply PyCI. And I'll note that we've really talked mostly about Py so far. So purpose, which is those two parts about purpose, which is it, can you tie it back to human needs, and does it clearly say what's in or what's out of the module. Interface. We've actually not talked a lot about how to make a good interface, but a big important thing for right now is that your interface should be smaller than your implementation. And we talked a bit about implementation, which is the I at the very end of PyCI. And really the interesting thing is the recursive nature of this modular lifecycle, that in order to continue to scale your code, you're going to be growing modules within modules. Literally, that's how it works. We've talked a lot about encapsulation at the various levels and how the various levels, some support encapsulation better than others, but all of them can do it quite well if you follow a regimen. What we have not talked much about is connection. And particularly once you have an ecosystem of modules, particularly mature modules, like an ecosystem of packaged modules, there's a whole, probably another video to talk about that scenario. But I will say just this one little bit. There's two little bits as you're starting to have an ecosystem of modules that are really, really good to keep in mind. One is don't ever have cycles or peer dependencies on modules. I do see people do this periodically, and it just creates dependency nightmares. Your modular dependency graph should always be a DAG, a directed acyclic graph, which is to say if you put all your dot modules as dots on a whiteboard, you should be able to draw arrows that go from left to right and connect all of the dependencies. And you should never have to draw an arrow that goes back or curves back from right to left. The other main thing for connection is just minimize your external dependencies. As with all things, you're trying to minimize complexity. External dependencies are something you don't have control over. Hopefully, they have a really strong interface to implementation. They have got really strong encapsulation, which is to say that they're as leakless as possible as abstractions, but there's no such thing as a totally 100% leakless abstraction. You want to minimize your external dependencies as much as possible, as with all things. That's really the process. And not to be too fine a point, those two key pro tips of dry things up every time you see them continuously and get really good at seeing when there's opportunities to dry things up, and treat folders fully as modules. And specifically their files and their subfolders are private, and it's totally okay to start by exporting everything and then start winnowing it down as you mature that module. And if you do all those things, you're going to be continuously maintaining a highly modular code base, which means that you will be continually in a world of logarithmic complexity scaling instead of quadratic complexity scaling. I'll leave you with that and say thank you very much for spending your time with me. And remember, all problems are solvable with enough knowledge and modular design.